Our article is titled Learning and Adaptation in Speech Production Without a Vocal Tract, presented by Natalie Frank, Paige Passadine, and Sophie Kalopoulos.
This study aimed to find how the act of speaking is learned. It is understood that auditory feedback is crucial in learning vocal speech production skills. For example, without cochlear implants, children born without hearing can rarely be taught to produce speech. This study aimed to prove that, independent of the vocal tract, speech production can be learned from internal location sound mapping, specifically in this study, a vowel formant synthesizer, meaning that speech production is a learned motor act.
The purpose of this study was to assess how speech production could be learned without the vocal tract. The first hypothesis asked if a touchscreen synthesizer would be able to help speakers create an internal map to generate speech sounds without the vocal tract. The second hypothesis targeted how speakers would use the mapping behaviors from the first hypothesis and apply that knowledge to the stimulus post-assessment. The third hypothesis assessed how speakers will use the trained sensory motor actions to go from internal audio-motor mapping to speech production behaviors.
All hypotheses were tested using a within-subjects design, meaning that all subjects experienced the same conditions throughout each experiment. For Hypothesis 1, subjects were tested using a touchscreen vowel formant synthesizer. They were asked to close their eyes and match spoken vowel targets using a touchscreen. Once they touched the screen, they received auditory feedback. For Hypothesis 2, subjects were tested with unaffiliated stimulus to test if learning in H1 was generalized. For Hypothesis 3, trained users should be able to differentiate between altered stimuli versus learned stimuli while working with the touchscreen formant synthesizer.
Overall, the authors found a positive outcome in using a touchscreen vowel formant synthesizer. The subjects were able to learn to produce the indicated vowel sounds independent of the vocal tract. The accuracy and consistency improved significantly throughout all 3 test trials. The results verify that the touchscreen allowed for an accessible mode of learning how vocal production and language development are dependent on one another.
This study shows that speech production learners are able to use mental mapping behaviors to learn speech production skills on both known and novel target sounds. This confirms the framework idea that speech is a learned motor act that we develop in early childhood by listening to the world around us. Creating a link between touch and auditory response further emphasizes the need for interaction between infants and developed speakers.
These results help us as speech-language pathologists to further emphasize early intervention practices to parents and other care providers. For example, we know that early infancy is a pertinent stage in development for making connections between speech and the world around them. Although infants cannot verify that they are learning language from interacting with other speakers, we know that they learn language by hearing others. Further, for clients who come to us for voice therapy, this study proves that feedback mechanisms can be helpful intervention strategies to utilize.
Our discussion question asks, while working with infants and toddlers who are learning babbling behaviors and experimenting with their own voice, have you noticed anything specific regarding the child's knowledge of their voice and how they learn to produce speech sounds?